Thank you for introduction and for organizing this session. I would like to present our recent results from Oddball study. Oddball task is one of the most popular tasks to evoke P3 wave, which is considered to be related to high cognitive functions and fluid intelligence. However, spatial-temporal characteristics of this component are not well demonstrated, and we aimed to investigate them by applying ERP-microstate analysis, which is topographic ERP analysis and can also show network activation. We asked several questions. What is microstates dynamics of stimulus processing in this three-stimuli visual Oddball task? Do rare stimuli activate additional microstates which represent different networks and additional steps of information processing? Also, do common information processing steps differ between conditions in the temporal dynamics? And what are Oddball microstates correlates of fluid intelligence? To answer these questions, we recruited 41 healthy participants and recorded high-density EEG. Our task consisted of 4 runs, and in each run, stimuli were presented one by one randomly, but were grouped in mini blocks by 4 stimuli, and breaks between mini blocks were a bit longer than between stimuli. Our standard stimulus was letter P, while deviant and target stimuli were modifications of letter P. And participants were instructed to press response button only when we saw target on the screen. In separate psychological session, we collected fluid intelligence data and used Raven's advanced progressive matrices. And for ERP analysis, we were interested in duration, area under the curve, and mean global field power of microstates. Here on the left, on the right at the top, you can see 8 maps of microstates which represented our data best. Each of them has assigned color, which shows where that microstate was present under global field power curve. So top line is for standard condition, middle one is for deviant, and bottom one is for target. And you also can see at the bottom wave shapes of all 3 conditions at FCZ and POZ electrodes. So to better understand what show GFP envelope, you can imagine that you flip your ERP to the positive side, and it looks similarly. So we observed that there are 3 different processes in deviant and target condition: early blue one, this olive one, and gray one. And they are not present in standard conditions. So they are additional to rare stimulus processing, and duration and area under the curve, both with global field power mean, so amplitude was higher in target condition. Also, we observed that there are some differences in common processing steps, namely microstates 5, this purple one, which represents early P3 component, lasted longer and had higher amplitude in standard condition compared to deviant and target conditions. So we asked question, if we can see these differences related to Raven scores. For that, we grouped our participants into 3 groups based on Raven scores and applied 3 by 3 factorial microstate analysis. So you see the same maps, and now in columns you see groups. The only significant difference was group effect for microstate 5, so this common processing step, and it showed that amplitude of this microstate was larger in group with lower Raven scores compared to medium score group and high score group. And interestingly, it did not differ between two groups with higher scores. Since we have this analysis, this difference in common processing step, we checked also if there are any differences in behavioral results. We did not find any differences in reaction time presented here at the top. However, there were significant differences in accuracy. And accuracy decreased from standard to target to deviant condition in all three groups. And also, low score group had significantly lower accuracy compared to medium score and high score groups, while as in microstate analysis, these two groups did not differ in accuracy. And these differences were driven by significantly lower accuracy in deviant condition in low score group. So to conclude, later P3 component associated in our data set to microstate 6 represented additional cognitive processes active during processing of both rare stimuli and possibly contributed to target discrimination from distractor, while the earlier P3 component associated with microstate 5 represents information processing step common across all three conditions and sufficient to recognize standard stimulus. And interestingly, this earlier P3 component also differentiated a group of subjects with lower scores of fluid intelligence from the two groups with higher scores of fluid intelligence, possibly indicating that this group of subjects with lower scores experienced difficulties to differentiate a rare target from both frequent stimulus and rare deviant stimulus, which was also supported by higher error rates in this group. So that were all findings, and I would like to thank you all for attention and also thank my colleagues and collaborators and funding source. And if you have any questions, please ask, and you can also email me and discuss further.
Okay, thank you so much, Ingrida. An interesting talk. We have a couple of questions already in the Q&A. So Anka asks, how were the microstates computed? Please elaborate.
They are computed from mean subject ERPs and grouped based on topographic similarity of single time point topographies. So it takes values of all electrodes, builds topography like a map, and then combines similar ones. And then the most common topographies across all groups, conditions and participants are recognized as this cluster maps. And then later we analyze our data using this cluster maps. So it's the simplest and shortest explanation.
Okay. So you do some clustering to identify those microstates?
Yes, yes. Okay. It was done using k-means clustering in this case.
Okay, so what do microstates represent biophysically? This is a question again by Priyanka.
They are suggested to represent neural network activation.
Mm-hmm.
And what can we see? For example, sometimes we consider ERP as one wave, but microstate analysis shows that within this wave, there are two processes So something similar happens at the beginning than at the end. Like here we have also this earlier P3 and later P3, and we can see differences. We plan to do some source reconstruction later to see what exactly is different.
And Levi sends us a paper related to this. I think this is like to answer Fianca's question. Thanks, Levis. And Levis also asked question for method clarification. So how were you able to drive an accuracy score to the standard and deviant stimuli? I assume that participants were only required to respond to target stimulus.
That's right, but sometimes they responded to a standard and deviant stimuli, and that was considered as errors. So we then computed accuracy scores.
Okay, thank you. So we still have time if there is any questions. So I don't see any more questions.
Can I ask a question?
Oh, sure.
Yeah. So, what do you think about MS4, so microstate 4? Because it's quite interesting. It's earlier, much earlier than P3. So, what do you think it might represent?
It may represent the beginning of P3 component, which is a bit different in this deviant and target condition. So already recruiting some additional processing. But it's not easy to interpret it now. It would be easier when we have sources. But it shows that something additional already is recruited than participants see rare stimulus.
Okay, Levis continues the question on standard versus deviant accuracy scores, and asks, why didn't you consider a sensitivity scores, like D prime, for example, which
talking about the behavioral, yes, scores.
These are D prime?
Can you repeat question?
The question is, why didn't you consider a sensitivity a score instead of accuracy?
I see. We did not consider that, but yeah, thank you for suggestion.
Yeah, it's a good suggestion, I think, because then you can compare detection and false false alarms, and it's a better comparison.